Welcome, everyone. Today, we're diving into building the Agentic analytics stack. If you've ever tried pointing an LLM at a data warehouse, you know it can be a messy process. But what if I told you Anthropic achieved around 95% automated query accuracy for self-service business analytics using Claude? In this video, we'll walk through a blueprint for moving past the false precision of raw LLM queries by architecting a highly structured, agentic system. Let's get started. Let's start with our core premise: data is not software. When we talk about coding agents, they operate in an open-ended solution space where creativity is rewarded, and guardrails like compilers and tests are built right in. Analytics agents, however, are a totally different beast. They navigate a highly ambiguous search space where there is usually only one single correct answer, and unfortunately, there's no deterministic way to prove that correctness. Pointing an LLM directly at your raw data warehouse creates a false sense of precision. Writing the SQL is actually the easy part. The real bottleneck is mapping the user's question to the correct entity in your database. Because of this bottleneck, we identified three main failure modes for analytics agents. The first is concept-to-entity ambiguity. When a user asks about active users, the model faces hundreds of viable options. Does that include fraudulent accounts? What's the look-back window? It often just guesses and gets it wrong. The second is data staleness. Schemas and business definitions constantly change, causing the agent's knowledge to rot and return subtly incorrect answers. And the third is retrieval failure. Even if the correct data is perfectly annotated, the sheer vastness of the search space means the agent can simply get lost and fail to find it. To tackle these failures, we built a four-layer solution called the Agentic Analytics Stack. Layer 1, Data Foundations, blocks ambiguity and staleness by governing the underlying data. Layer 2, Sources of Truth, directly defines the correct metrics to block entity ambiguity. Layer 3 is Skills, which helps the agent navigate the space and blocks retrieval failure. And Layer 4 is Validation, which catches any leaks and prevents silent failures. The key takeaway here is that analytics accuracy is fundamentally a context and verification problem, not a code generation issue. Let's look at Layer 1, Data Foundations. Instead of letting the agent sift through dozens of plausible tables, you need to curate one single governed canonical dataset. You do this by aggressively deprecating near duplicates to shrink the space of plausible entities. But curation isn't enough, you have to enforce your standards using tooling and CI checks. Without enforcement, your models will just decay back into multiple conflicting candidates. Finally, treat your metadata as a first-class product. LLMs demand a legible warehouse, so column descriptions, valid value ranges, and lineage must be rigorously maintained. Now, here is our secret weapon for maintaining these foundations: collocation of artifacts. The biggest threat is that changing a data model will break the downstream knowledge of your agent. Our fix? Complete collocation. We keep transformation models, semantic logic, reference docs, and dashboard definitions in a single repository. By using cross-layer CI checks, if a modeling change invalidates a metric, the build fails. The fix then has to ship in the exact same PR, ensuring cross-layer integrity. Moving to Layer 2, we establish our sources of truth. Think of this as a funnel. Level 1 is the semantic layer. This is the structural first stop for compiled metrics yielding a single definitive number. If that fails, the agent moves to Level 2, lineage and graph, to find upstream model aggregations. Level 3 is the query corpus, which consists of distilled, structured reference docs based on historical analyses. And finally, Level 4 is business context, things like company roadmaps and org charts to resolve ambient, non-technical references. You might be wondering about that query corpus. Here is a fascinating procedural insight on why raw retrieval actually fails. We ran an ablation test where we gave the agent direct grep access to thousands of historical SQL queries. The result? Accuracy changed by less than 1%. Our diagnosis showed that the agent actually saw the correct historical query 80% of the time, but couldn't successfully map the new question to the correct precedent. The takeaway here is simple: structure beats access. Distill your query history into structured reference patterns rather than relying on raw, unstructured search. Next up is Layer 3, Analytics Skills. Moving from raw data access to curated, on-demand markdown files completely transformed our system. Accuracy jumped from 21% to over 95%. We use a pairwise architecture for this. First, a knowledge skill acts as a top-level router that preemptively narrows the search space from millions of fields down to a few dozen curated files. Second, an unbook skill encodes the workflow of a senior analyst, clarifying questions and executing reusable patterns like funnels and retention curves, so the agent never has to reinvent the wheel. But skills require maintenance. We found that without active maintenance, offline accuracy drifted from 95% down to 65% in just 1 month due to knowledge decay. So, we introduced a CI hook. 90% of our data model PRs now mandate a corresponding skill markdown change in the same diff. And to ensure a seamless experience, we built omni-channel portability. One canonical source syncs seamlessly across IDEs, Slack, and cloud apps via the Model Context Protocol, meaning there are no hard-coded repo paths. Now for Layer 4, the validation engine. We split this into offline and online validation. Offline evals anchor our ground truth through dashboard-based common queries and long-tail plausible edge cases. We treat these like telemetry, rerunning them in CI to gate our domain launches. For online validation, we rely on production telemetry, provenance tracking to signal data freshness, adversarial review to challenge assumptions, and passive monitoring to track our semantic layer resolution rates. To tie it all together, we have a continuous improvement cycle we call the correction loop. Step 1. An active agent harvests stakeholder Slack channels looking for correction language, like someone saying you're missing the fraud filter. Step 2. The agent autodrafts a one-line markdown fix and tags the domain owner. Step 3. A human reviews and merges the PR, which is a deliberately boring, low-friction task. Step 4. That correction feeds back into the offline eval set, hardening the system against future regressions. Now, a quick note on the latency versus accuracy trade-off. We deployed a subagent to aggressively challenge underlying data assumptions before outputting a final answer. The impact was great, a 6% boost in accuracy. But it came at the cost of 32% more token usage and a massive 72% increase in latency. We tried swapping to a cheaper model for this step, but it lost the accuracy gains without a real speed-up. So, the takeaway is to apply this tactic selectively based on your specific use case risk tolerance. Perhaps the scariest issue is the silent failure, when an answer is factually incorrect but visually and contextually plausible, and gets passed up to leadership without objection. We used 3 mitigations for this. First, a provenance footer that appends the source tier, data freshness, and model ownership to every single response. Second, structural barriers that require explicit human sign-off for any leadership-bound data. And third, daily standing evaluations that sanity check the agent's KPIs against your blessed company dashboards. Finally, let's look at the deployment blueprint. If you're starting from zero, you can get 80% of the value by building a handful of canonical datasets, a few dozen offline evals, and a thin knowledge skill router. As you scale toward the enterprise level, you'll need to make decisions about your audience's technical tolerance, your budget for accuracy features like adversarial loops, and your privacy constraints regarding global versus scoped data access. Ultimately, the objective remains constant: collapse ambiguity into a single governed answer, ensure that answer is discoverable, and flag data staleness aggressively. Thanks for watching.